Okay, so for this week, I chose to do a problem from the 4-5 assigned homework section, Chapter 4, Section 5 homework, and it was asking you to form a third degree polynomial function with real coefficients such that -1 plus I and 8 are zeros. And since what we learned about the complex conjugates and all that makes -1 minus I also have to be a zero. And so then we use the factor theorem and we turn it into a times x minus 8 times, and you can see that, just wrote out those complex roots, complex zeros, and then we simplify it a little bit because it's kind of messy, and we make it x minus 8, or a times x minus 8 times x plus 1 minus I times x plus 1 plus I. And then we can use the distributive property the first time, and we get a really long string of i's and all that. And the I squared basically lets us simplify it. You can see this in the example, down to x squared plus 2x plus 2. So that whole long string just goes to x squared plus 2x plus 2. So then it's a times x plus 8 times x squared plus 2x plus 2. And then we use the distributive property again, now substituting in a equals 1 as the value to finish the multiplication of the factors. And so we get a times x minus 8 times x squared plus 2x plus 2, which just turns into x minus 8 times x squared plus 2x plus 2. And then when we multiply that out, we get that big long string, x cubed plus 2x squared plus 2x minus 8x squared minus 16x minus 16, which simplifies to x cubed minus 6x squared plus, minus 14x, not plus 14x. A little correction in the midst of the video, but and that's going to be our grand answer. All of the terms here are negative except for the leading coefficient, x cubed. So it was a kind of easy problem to solve once I knew what was going on, but it definitely took a little help from viewing example, and I'm very sorry for writing so small and filming in a fairly dark location, but I hope you can see it, and hope you're having a good Sunday night or whatever time you're watching this video. Thank you.